Open your book to page 321 and let's go to number 1. In number 1 you have two vectors. You got vector A is equal to AI plus 8j minus 4k. Vector B equal to I minus 2j minus 3k. And you're looking for A dot B. And you're looking for cosine of the angle, cosine theta. Okay, so this is what you're looking for. So A dot B, you just multiply. So A dot B equal to, you just multiply. So 8 times 1 equal to 8 plus 8 times negative 2 give you negative 16 plus negative 4 times negative 3 is equal to 12. So A dot B equal to 4. Okay, for the next part, to find cosine theta, again you start with your equation. So 8 dot B equal to A B cosine theta. So cosine theta, you have to get rid of the, so divide. You get 8 dot B over A B equal to cosine theta. Go and substitute all the numbers in there. We already have A dot B. A dot B is 4. And then the length of A from here, you're going to get square root of A squared. So that's 64 plus 64 plus 16. So that's length of A. And length of B, 1 squared is 1, negative 2 squared is 4, 3 squared is 9. Okay, so you're going to get 4 over, this is going to be square root of 144, so this is 12. This is square root of 14. And you can simplify and multiply by square root of 14. So you got square root of 14 over 42. Okay, and that's it. Okay, let's go to number 7. Number 7. Okay, I'm not going to write the arrow anymore. So right now the letter will just represent the vector. So vector A is 4i minus 4j plus 2k. Vector B is I plus j plus 2k. So again, these are vectors. So I'm going to save time. So I'm not going to write those arrows. So you're looking for the scalar projection and the vector projection of B on A. Okay, so you want looking for B on A. That means you want to put B on top and the A on the bottom, so you can have B on A. So the part that you're looking for, the scalar projection is a length. Okay, so this length over here is going to be equal to, so this length over here is V, absolute value of B, and this is A. And here's your theta. So this part is going to be equal to B cosine theta. Okay. So again, here's a B. You times by cosine theta will give you that length, and that's your scalar projection. So you start with your the equation. So you got A dot B equal to A B cosine theta. And the part you're looking for is B cosine theta, so this is the part that you're looking for. That's the part you're looking for. So you have to get rid of the A, so divide by A. You get A dot B over A equal to B cosine theta. Okay, so go ahead and just substitute. So over here, so you multiply. So A dot B is going to equal to 4 plus negative 4 plus 4 divided by length of A, so it'll be square root of, I can use that, so you square that, you get 16. 16 plus 4 equal to B cosine theta. So go and work it out. You're going to get 4 over, this will give you square root of 36, which will give you 6. And then you simplify, so you're going to get 2/3 equal to B cosine theta. So in other words, the length of that, so the length equal to 2 over 3. Again, B cosine theta is the length, or the scalar projection. Okay. Now let's go and do the vector projection. So this is the scalar. Now let's go and do the vector projection. So vector projection is, again, is this one over here, but instead of length, you need to get a direction also. Okay, so you have to get direction and a length. So first, what you need to do is, you want to get the direction. So this is same direction as A, so you start with the A vector. You can always take care of your direction. So take care of the direction, and then you want to divide it by its length to get a length of 1. Okay. So the length of A is, again, square root of 16 plus 16 plus 4. So this will give you a length of 1. Right? This is a unit vector. Right? Again, this is the vector A divided by the length of A, give you length of 1. Then you have to times it by the length of 2/3. Okay, so this is to get the direction correct. This is to get the correct length. Okay, so now you go and work it out. So you got 4i minus 4j plus 2k over 6 times 2 over 3. And you can go and cancel these things out. So this will equal to 4 over 9i minus 4 over 9j plus 2 over 9k. And this will be your vector projection. Let's go to number 9. Okay, number 9, you have vector A equal to I minus j minus k, and vector B equal to 5i minus 12k. And now this time you want to have an A on B. Okay, so A on B, that means you want to put A up here and put a B against A on B, right? And so this is the length of A, and this is theta, and I'm going to put B up here, so this is the length of B. Okay, so again, scalar projection means you're looking for this right over here. So this part would be, you start with the length of A times the cosine theta, and that's what that is. Okay, and so that the length of that is equal to that. Okay, so again, the length of this this vector is this length times cosine theta. And again, you start with your equation, A dot B equal to A B cosine theta, and the part you're looking for is this part and this part over here, and you're looking for A cosine theta, so you need to get rid of B. So A dot B over B, again, see, when it's A on B, that means you're going to have the dot vector, dot product on B, right? Again, if it's on B, it's going to be on on B. So this will equal to A cosine theta. Okay, so go and work it out. So A dot B, again, you multiply. So you're going to get 5 plus 0. Right, there's no J over here, so it's 0, right? Plus 12, and watch for your sign, over Now, the length of B, you can see it's 5, 12, 13. But if you don't see that, you can just go square that. So you get 25 plus this one would be 144 equal to A cosine theta. So you work out, you're going to get 17 over, and this one again, this one will give you 13. Okay, so that is your vector projection, the scalar projection. That's the length. So length is equal to 17 over 13. Okay, so again, this is your scalar projection. Okay, now work on the vector projection. The difference between the scalar projection and the vector projection, the scalar projection is just the length. This is the direction and the length. Okay? So again, first you always have to get your direction correct. So this is the same direction as B. So you need to start with vector B. Okay, but now this is the wrong length. Okay, because this is length of 13. So you need to get to length of 17 over 13, right? So first, you need to divide by its length to get a length of 1. Right, so you can divide by its own length. So this has a length of 1. So this is a unit vector. So now you have length of 1. Now to get to 17 over 13, you just multiply by 17 over 13. So you can first get the direction correct, then divide by its length to get the length of 1, and then you multiply to get the correct length. Okay, and you simplify that again. This is a 5, 12, 13 spatial triangle. And then you work out the math. So you got vector V equal to 85 over 169I minus 204 over 169K. And that would be your vector projection. Okay, let's go to number 11. In number 11, you have vector A equal to I plus 3j minus 5k. Vector B equal to 4I plus 2j plus 2k. So first you want to do is you want to check if they are parallel, and the way to do it is by looking at the direction number, see if they are one is multiple of the other. In this case, they're all scrambled, so it's not. So they are not parallel. So next thing you have to do is check for if a perpendicular. So you take the dot product to see if it's equal to 0. So you multiply, you get 4. Multiply, you get 6. Multiply, you get negative 10. So A dot B equal to 0. So in this case, it's perpendicular. Okay. Let's go to number 13. You got vector A equal to 6I plus 9j minus 15k. Vector B equal to 2I plus 3j minus 5k. Now what you want to do is notice this can be factored. So go and factor out the A. Factor the vector A by 3. So you get 2I plus 3j minus 5k. So from these, again, so you can see that these are parallel. And A is 3 times the B. Right? Again, look at direction number is 2, 3, negative 5. So when you have vector, you always check parallel first. See if one is multiple of the other. So in this case, it's parallel. Okay. And if you draw the vector, this is what it looks like. This is vector B, and you're going to get A is 3 times. Right? So A is 3 times B, and that's what it means. So you can always check, see if one is multiple of the other. If they are, then it's parallel. Now, if the sign is negative, it means they're opposite direction, but it's still parallel. Okay, then after that, you check, see if they're perpendicular. A dot B equal to 0, then it's perpendicular. And if it's neither, then it's neither. Okay, let's go to number 15. Okay, number 15, you have a cube. Okay, so you have this over here, and you also want to have an angle between the diagonal and the edge. So you're looking for this angle theta over here. So this point is 1, 1, 1. And this point is 1, 0, 0. Again, you can use any number, but it's just like a similar triangle. It doesn't matter what size you use, so use 1 is the easiest. And so that's going to call this vector P, and this is vector Q. So vector P equal to I plus J plus K, and vector Q equal to I, and that's it. And so again, if you start with your equation A dot B equal to A B cosine theta, right? So you want to find the angle between, so you have to divide. So in this case, you're going to get P dot Q equal to P Q cosine theta. Then you divide, you get P dot Q over P Q equal to cosine theta. So put in the numbers, you got 1 plus 0 plus 0 over square root of 1 plus 1 plus 1, right? And get Q, you're going to get 1 plus 0 plus 0 equal to cosine theta. So cosine theta equal to 1 over square root of 3, square root of 1. You simplify, and you can just use a calculator to work it out. So you're going to get 54.7 degrees. And so that's it.